So we are dealing with the first problem in work, energy and power segment. The problem is stating, in the arrangement shown in the figure, the mass of the body 1 is 4 times as great as that of body 2. The height h is equal to 20 centimeter. The masses of the pulleys and the threads as well as the friction are negligible. At a certain moment, body 2 is released and the arrangement is set in motion. What is the maximum height that the body 2 will go up to? So this is what the problem is stating. If we look at the situation which the problem is describing us, so this one is the first block, this one is the second block, and this one is the height which the problem is referring to. Now according to the problem, the mass of first block is 4 times the mass of the other block. So if this one is of mass 4m, then this is the mass m that we have. If we identify the forces, then over here I can say that a weight of 4 mg will act in the downward direction, and here a weight mg will act in the downward direction. If we do the tensional analysis in the system, so if this thread will have a tension T, then the tension will be transmitted to all these threads connected together, and this one will have a tension 2T. If this block is going down with velocity v1, then this block is constrained to move in a certain way that it will move with a velocity v2. So the first step while solving this problem is to write a constraint equation between the block 1 and 2. So what we are doing is establishing constraint relation between the blocks. So over here we can directly write the expression 2t minus v1 plus t v2 is equal to 0, and therefore we can write that v2 is equal to twice v1, by means of which we can say that if this block will move with a velocity v1, then the v2 is equal to twice v1. So if we take v1 is v, then v2 is equal to twice of v. So this is the first thing which we have done in this problem, is that we have established a constraint relation. Similar to this constraint, we can also say that as this block is going to move down by a distance h and hit the surface over here, the block 2 will rise by a height of 2h. To understand this aspect, let us see another diagram over here. So over here we have matched out the constraint relation v and 2v and the height relation, that if this block will come down by a height h, then m is supposed to rise by 2h. But 2h is not the final answer for this problem, as over here many other things are involved. So as the first block will strike the ground and come to a halt, the string in the system will slack, and after the string in the system is slacked, the block 2 will continue to move under a free fall condition in gravity. So it will come under gravity and will continue to move further. So to solve this case, we are writing energy conservation statement between the first scenario and the second scenario. So we are writing initial energy of the system must be equal to final energy of the system. The initial energy of the system consists of two aspects: kinetic energy initial plus potential energy initial. This must be equal to kinetic energy final and potential energy final. So if we come to this initial state, so at this initial state when the system is released, there is no kinetic energy at all in the system. So the initial kinetic energy of the system is 0. The initial potential energy of the system is stored in the block of mass 4m, which is at a height h. So we are writing this as 4 mgh. Now for writing kinetic energy final of this system, we have this situation shown where the block of mass 4m is moving with velocity v. The block of mass m is moving with velocity 2v. The block 1 is in touch with the reference level, or which we have considered as a ground level, and block of mass m is at a height 2h. So this is the energy equation which we can write between the initial case and the final case. On rearranging the terms, we have 4 mg equal to, we can subtract minus 2 mg, h equal to 2 mv square plus mv square. So on solving this, we have 4v square to 2mv square here also. So over here we get 2gh equals 4mv square, and therefore v square equals gh by 2. So v can be written as gh by 2 square root. So now if we proceed the problem further, so I can say that the block 2 will be having a speed 2v in the upward direction. Therefore, twice of root over gh by 2, this can be written as 2gh. So this is the velocity which the block 2 is having, and now from here onwards the block 2 is in a state of fall under the gravity. So we can consider it this way, that this is the block 2 which is having a mass m. It is under gravity moving with a velocity v, where v equals root over 2gh, and it will, since the string is slacked, so we are writing the string is slacked, and the block 2 is moving under influence of gravity. So therefore, so it will continue to rise to a height where it comes to a momentarily halt, attaining a certain height, say h0. So if we solve this, we say that the initial velocity can be taken as root 2gh, final velocity is 0, it is under